Today we are going to talk about the sum of an arithmetic progression, and I will just briefly introduce a problem which relates to finding the sum of an arithmetic progression. Suppose we have the following arithmetic progression, say 1 plus 3 plus 5 plus 7 plus ... all the way up to 999. When you first look at that problem, you might think it is quite difficult to solve. And sometimes in mathematics, when you have a problem which is difficult to solve, you might want to find a simpler problem which is somewhat related to the original problem. So this is the original problem we are trying to solve. And it might be difficult to find a way to find the sum of all of these terms right here. So let's start by looking at a simpler example. This is just a baby example in order to solve the original problem. Say we have 2 plus 4 plus 6 plus 8 plus 10. Well, if we want to find the sum of this arithmetic progression right here, we can simply just add the terms and it equals to 30. Another way is to say, well, 2 plus 10 is equal to 12. 4 plus 8 is equal to 12 as well. So we have 2 multiplied by 12 plus the last remaining term here, which is 6. So the sum of the term is equal to 2 multiplied by 12, which is 24, plus the remaining 6, which is equal to 30. Okay, with that in mind, let's look at something else. Well, another thing is that we can clearly see in our so-called baby example that the nth term has the value 2n. What I mean is that if we have a function, say fn, then we can describe the nth term of the arithmetic progression above as 2n. Say, because, well, if we have f1, that is simply equal to 2 multiplied by 1, which is 2, and f2 as well is simply equal to 2 multiplied by 2, which is 4, which is the second term of the arithmetic progression, and the first term is 2 as well of the arithmetic progression. So we found something which we can somewhat use to analyze the arithmetic progression. Okay, now let's turn back to the original problem. Now we have some more tools that we can think about when we're trying to solve or kind of figure out a solution to the sum of an arithmetic progression. So in the baby example above right here, I showed you that there's a relation of this kind of arithmetic progression. We can see that all of the terms in the arithmetic progression consists of even numbers. In the original problem though, all of the terms of the arithmetic progression consist of odd numbers. So actually we might be able to see fairly quickly that we can describe the value of the nth term of the original problem as 2n minus 1. That is simply the case because, well, f1 is equal to 2 minus 1, which is equal to 1. f2 is equal to 4 minus 1, which is equal to 3, and all the way up, which is the second term is equal to 3, and the first term is equal to 1. Which is the same in our problem. It can be shown by induction, but right now I'm just giving you the intuition. Okay, so right now we have figured out that actually the nth term of the real arithmetic progression of our kind of real problem is equal to 2n minus 1. And now we want to figure out something else. We want to figure out how many terms is there in the arithmetic progression. Well, we can simply say that 2n minus 1 is equal to 999 if and only if 2n is equal to 1000, if and only if n equals 500. So we can see that the progression of the original problem contains 500 terms. Okay, so that is some good news. So what do we do now? Well, one thing we can do is that we can say we can split up this entire arithmetic progression in pairs. So if we want to split it up in pairs, we simply get 500 divided by 2, which is equal to 250 pairs. And the first pair, say we take 1 plus 999, we simply take the first term plus the last term, second term plus second last term, just as we did in the baby example above. Plus 3 plus 997 plus 5 plus 995, and I think you can see where this is going, plus and so on. Well, in that case, what can we do now? We can say, okay, we have 250 terms, or pairs actually, we have 250 pairs. And each pair has the value 1000. So we can say the sum of the arithmetic progression of the original problem is simply 250 terms multiplied by the value of each term, which in this case is each pair. So we have 250 pairs multiplied the value of each pair, which is 1000, which is equal to 250,000. So the sum of the arithmetic progression 1 plus 3 plus 5 plus 7 plus dot 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 plus 999 is simply equal to 250 multiplied 1000, which equals 250,000.